Yes, class. The lecture for today is selection sorting. First of all, we will see what is sorting. After that, we will implement all these sorting one by one, and we will also see how many types of sorting are there. So the topic starts today is sorting. So first of all, the definition of sorting. What is sorting? Sorting is any process of arranging items systematically, or you can say to separate according to types. Now for sorting we need algorithm for the sorting of a list, or you can say a collection of elements. So what is sorting algorithm? An algorithm that puts elements of a list in a certain order. The types of sorting are the types of sorting are: first, selection sort; second, insertion sort; third, bubble sort; fourth one is radix sort; fifth one is heap sort; and sixth one is merge sort. So these types these are the types of sorting. So we will learn all these sorting one by one. So first of all we will see what is selection sort. Selection sort. In selection sort we divide the list of elements into two parts: the sorted part and the unsorted part. Okay, this is the first thing we do in the selection sorting process. We divide the whole list we divide the whole list into two parts, that is sorted part and unsorted part. Second step, first of all we find the smallest element in the list. Smallest element in the list, or you can say in the smallest element in the unsorted list. Unsorted list. Okay, unsorted list, and swap it with the element at the beginning of the unsorted list. The third step we will do here, after each step of selection and swapping, the unsorted list increases by 1, and unsorted list the sorted list increases by 1 and the unsorted list decreases by 1. Okay, the fourth step we do here, it is about the selection sort. The one pass completes when we move an element from unsorted to sorted list. Okay, this is the one pass. We perform selection sort into n-1 passes of n elements. Okay, this is the procedure for selection sorting. Now we will take an example and we will see how it works. Okay, so the example we are taking here, this is the sorted part of list and this is unsorted. All these elements are 35, 28, 9, 7, 14, 6, 11. Okay, first of all we will find the smallest element in this unsorted list, and this element is 6. So we will swap this element with the first element. Okay, this element, the smallest element, with the first element. Okay, so we will take here this is 6 here comes the 28, 9, 7, 14 and 35, because these are swapped by with each other, and 11. Okay, now we will this is the sorted list and this is unsorted list. Now now again we will find the smallest element in the unsorted list. So unsorted, the smallest element after 6 is 7. Sorted. So now we have two elements, 6 and 7, and in unsorted list we have 28, 9, 7 is 14, 35 and 11. Okay, after that the next smallest element is 9. So 6, 7, 9, 28, 14, 35, 11. You can say the sorted list is going bigger and the unsorted list is going with each step smaller. Okay, after that sorted list we will find the next smallest element, that is 11, 6, 7, 9, 11 and 28, 14, 35. This is unsorted. After that the sorted part of the list is going bigger and bigger. 6, 7, 9, 6, 7, 9, 11. After that the smallest in these 3, 14, 28 and 35. This is unsorted. After that six, 7, 9, 11, 14. Now smallest in these two is 28, so we will keep 28 here. This is sorted part and this is unsorted part, 35. After that 6, 7, 9, 11, 14 and the last element 35, which is the smaller in this list, 35. So this is the sorted list. Okay, so in this way with the use of selection sorted, our list has been sorted with the help of this selection sort. So algorithm for the algorithm we also have an algorithm for that. This is the algorithm. You can see algorithm selection, we pass array and number of elements. Okay, so we start loop here for I is equals to n minus 1 step plus 1, that is I plus plus. Okay, so we will assign min is equals to I. Okay, the next loop start from j is equals to I plus 1 to n. This is the loop here ends with n minus 1. The loop here will end at n step plus 1, same. So we will check the condition if ith element of A less than the minimum element of A. If this condition is true, then minimum element will become J. Okay, so we will swap means we will assign their value, we will swap their value with these, their value will be swapped. So this loop will stop here, and this loop will stop here, and this algorithm will stop here. This is the algorithm for selection sort. Okay, now complexity for selection sort. So if we analyze this algorithm, we are the steps, or you can say the comparison are there. Two loops are there, one is this and one is this. This is n and this is also n steps are there. Okay, and comparison also there. So the complexity for the selection sort is big O notation n square. Okay, this is the complexity for, you can say, selection sort. Okay, thank you.